This video was made possible by Brilliant, a problem-solving website that teaches you how to think like a scientist. I've covered a lot of people's crazy ideas in the past on this channel. There was the plan to drain the Mediterranean Sea, the plan to nuke a hole in the ground to create a new sea, and several other lunatic things. But sometimes an idea is so insane that it causes you to seriously wonder who on earth came up with it. Enter the man Jeffrey Pike and his wild idea during the Second World War to build a freaking aircraft carrier out of ice. While that doesn't immediately seem to make any reasonable sense, allow me to explain why it sort of did at the time. One of the biggest problems that Britain was facing in 1941 and 1942 was the fact that German U-boats in the Atlantic were sinking huge amounts of Allied cargo and shipping. Britain's greatest advantage and disadvantage during the war was the same thing. They were located on an island. This helped to prevent a German land invasion from happening in 1940, but it also meant that all of their imports from other countries had to be coming in by ship. And if the Germans could sink enough of it, it might mean that Britain would starve. This map here shows every single Allied ship that was sunk by German U-boat activity during 1941, and you can see a pattern emerging when you take into consideration the range that the Royal Air Force could operate in, represented by these arcs. A huge zone of the Atlantic was simply out of range for any planes in the RAF taking off from bases on land to reach and defend. And so this zone was where most Allied shipping was sunk, and it came to be known as the Mid-Atlantic Gap. The Royal Navy couldn't simply produce more aircraft carriers to patrol the area during wartime because the steel needed to create those ships was required for other more critical purposes like guns, tanks, bombs, and planes. And so in 1942, Jeffrey Pike believed that he had come up with a solution. While steel may have been in critically short supply for Britain during the war, two things that weren't were wood and ice. Pike began studying icebergs and thought, hey, you know what would be cool? What if we took one and shaved off the top to create a runway, dug out the center to create a hangar to put planes in, and then dropped it in the middle of the Atlantic before it melted? There were a few problems with Pike's ice Death Star idea though, namely that icebergs are way too small for that. Most of an iceberg is underwater anyway, and probably worst, icebergs sometimes randomly tip over, which wouldn't be a 100% ideal situation. But what if instead of taking an iceberg from nature, they created their own iceberg and made it look like a ship or an aircraft carrier? The idea was born in 1942, but creating a ship out of pure ice wouldn't do because, well, ice is ice and it has a bad tendency to melt and to sink. So instead, Pike and a team of scientists developed a new material specifically for the ship that they called Picrete. Basically just a mixture of water ice and wood pulp that wouldn't sink and significantly enhanced the strength and the melting time of ice. As a material, 1 ton of ice only requires 1% of the energy needed to produce 1 ton of steel. So in theory, it should have been a lot cheaper to construct a whole carrier from Picrete than from steel. But in practice, that wasn't exactly how it would turn out. Starting in 1943, the British created a small-ish prototype of the Berg ship on a lake in Canada that was 18 by 9 meters wide and weighed 1,000 tons. The full plan, however, called for the creation of the largest ship that would have ever been created, dubbed Project Habakkuk. The full ship was supposed to be 1.2 kilometers long by 180 meters wide, which is unbelievably stupidly huge. For reference, that's a boat that's bigger than some countries. Here is the ship placed over top of Vatican City. Here is the tallest building in the world placed next to it, and here is the actual biggest ship ever created placed next to it. It was absolute lunacy, but even more insanely, they thought they could construct one for only 700,000 pounds, which is only about 31.3 million pounds today. For further reference, just one Queen Elizabeth-class carrier in the current Royal Navy costs about 3 billion pounds. It was calculated that the amount of wood pulp needed to produce a carrier this massive would have had a serious effect on the Allied supply of paper during the war, while the Picrete material itself was proving to be fairly tricky to work with. In order to prove how durable of a material Picrete actually was, apparently an admiral brought 2 different blocks with him to a convention in 1943 Quebec, with Churchill and Roosevelt present. One block was normal ice, while the other was Picrete. The admiral pulled out his pistol, shot and shattered the ice block, then turned and shot the Picrete block and experienced the bullet bounce off and ricochet and graze another admiral present across his leg. Needless to say, Picrete was much tougher than regular ice was, but it still suffered from other similar physical properties, namely cold flow, or the tendency of ice to sag. The prototype ship in Canada was sagging, which meant that more steel reinforcements were needed than previously thought, and more effective insulation was needed around the ship's hull to prevent everything inside from melting even further. If the full model ship was ever actually built, steam turbo generators on board were going to provide 26 external electric motors around the ship's hull with 33,000 horsepower. The motors couldn't be placed inside the ship because of all the heat that they would be producing, while a massive refrigeration plant would be located somewhere inside instead that would keep the interior just nice and freezing. All of the crew on board would be literally living and working inside of these freezing conditions for months on end, like they were basically in the Arctic. 150 total planes divided between bombers and fighters could be stored on board the ship and made ready for takeoff, while the surface would be equipped with dozens of anti-air guns and small cannons. However, all of this extra steel required for the refrigeration plant, bracing, and insulation of a ship of this ridiculous size was beginning to appear to be stupidly impractical, obviously. According to one American study, the amount of steel required by a 1.2 kilometer long ice ship would be more than the steel required to build an entire fleet of conventional aircraft carriers, which kind of defeated the entire purpose of it in the first place, to save steel. And by 1944, a lot of other things were happening that basically killed the Habakkuk iceberg ship anyway. First, Portugal decided to open up their airfields to Allied planes in the Azores, which greatly extended Allied range out into the Atlantic. Second, longer range fuel tanks were allowing British planes to fly for longer and further out into the Atlantic anyway. And third, and probably most importantly, the Americans were starting to get heavily involved in the Atlantic and were introducing their own escort carriers. All of these factors combined made creating a kilometer-long ice ship look like the stupid idea that it really was. An idea made out of desperation, rather than an idea made out of cold science. If you think you can design a better ice ship, you'll need a pretty firm grasp on things like physics, classical mechanics, water flow, displacement, thermodynamics, and more, and all of those things you can learn on Brilliant.org. Brilliant is the expert in teaching regular people like you or me complicated things through active learning and problem solving. You can even learn something new every day with their short daily challenges, which each tie into one of their full interactive courses if you want to learn even more. If you like watching things on this channel, I know that you enjoy learning about things for free, so head over to brilliant.org/RLL to sign up there for free, and then, by being one of the first 200 people to use that link, you'll also get 20% off of their annual premium subscription, so you can view all of the daily challenges in the archives and unlock dozens of problem-solving courses and be supporting RealLifeLore at the same time while you're at it. Thank you for watching, and I'll see you next week for another brand new video then.